center of area, or more formally centroid of an area, right? Centroid. Think about the area. In area, we don't really care about the z dimension, right? It's just x, y. We're talking about area, two-dimensional space. So let's see, how can we find the centroid, center of an area? If this is, let's say, a rigid body, some rigid body, and say, since we're finding the center of area, let's say it has some thickness that we don't care about, but it has to make our life easier and make it easier to follow. Let's say it has a constant thickness, some kind of plate. It has some thickness T. And still we have an element of this looking at that element. Now for that element, let me write it. I should draw it this way. This element has an area, right? This is the area of the element, dA, in this plane on one surface. And also has some volume and some mass. If you go deeper into through this thickness, through this plate, it has some volume. It has dW, or better, let me write it this way. You can say delta W is delta mg, and that would be, you can replace delta m with rho delta v, so that would be rho delta vg, and then delta v of the volume of this element is basically delta A dA, or delta A, whatever is the thickness, multiplied by whatever is the area multiplied by thickness. Right? We find the volume of a cube. We find the area, multiply that by the thickness. So this becomes a rho delta A Tg. If you want to write it more for an element, dW is equal to rho Tg dA. Right? For the whole plate, what is W? The weight is the volume. Right? It's rho TAG, and then we'll say, well, area times thickness is the volume. Volume times density is m, right? So the weight is mg, m is rho v, v is area times thickness. Right? For one element, you can also follow the logic this way. For one element, dw, rho, t, and g are constant. They come out dA. Right? This is going to be the weight for one element as a function of area, if the thickness is constant. Right? If the T is constant, there is no differentiate comes out. So going back to what we started, these two fractions, x bar was x1 delta w1, x2 delta w2, and going on to xn delta wn. Right? You can actually rewrite this now as this. You can write x bar is equal to x1, and instead of delta w1 right here, this delta w here, you can write for one element as rho delta a, rho tg delta a1. Right? For each element is rho tg delta a1 plus x2 rho tg delta a2 plus dot 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 rho xn rho tg delta an. And at the bottom, w is rho t a g, and the same story for y bar. Becomes y bar rho tg delta A1, Y1, Y2, rho TG, delta, I can do that. Y2, rho TG, delta A2, dot, 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 plus Yn, rho TG, delta AN. All right, divided by rho TGA, right, for the whole structure. And the same story, like the top one is, you can say, well, this is basically nothing but, okay, you factor out rho TG, right, from the top and from the bottom, so you can cancel them out. Right? This one, and this one, you factor it out, and you cancel that with rho TG. Let me write it as rho TG, so it's easier. Rho TGA, and you can cancel them out. So what is left from the top is x1 delta A1 plus x2 delta A2 plus x all the way to the end, xn delta AN over A. Right? So we get, and from the bottom also rho TG, rho TG, rho TG, rho TG. What is left is y1 delta A1, y2 delta A2 to yn delta N over A. Now, again, the same story. A is nothing but summation of areas from IA to N AI, and the same story here, I to N AI. So we get a summation. The top one, in the numerator, you'll get summation XI AI from I to N, and from here you get summation I1 to N YI AI. So same story. If similar to what we did, n goes to infinity, meaning that this plate is formed by infinite number of particles. So n goes to infinity. This summation becomes an integral. Right? So this becomes x bar as integral x dA over integral dA, and y bar becomes integral y dA over integral dA. These are going to be your, how you can find the center of the coordinates of the center of an area, or centroid of an area, or for simply sometimes you put just centroid. All right. All right. So hopefully you follow the logic. What happens here? Center of gravity. Now we can calculate, assuming that given that we can calculate these integrals. We can calculate center of gravity. We can calculate center of mass. We can calculate center of volume. We can calculate center of area or centroid of an area. Right. And assuming that we know how to calculate these integrals. The same story for center of a line. Right? Center of a line, I don't really try to prove it, but if you have a line, in just simple line, let's say we have x and y here. You have x, you have y there, and you have some simple line here. And you're trying to find where is, and by line, I mean in engineering term, you can think of this as a wire. You're trying to find the center of a wire. Where it is, well, in this case, it might not end up being on the wire. You might get the center of wire somewhere here, I see. That will be some distance x bar from y-axis and some distance y bar from x-axis. That's not, you get it somewhere, but it might not be on the wire unless it's a straight wire or it's a straight rod. Very thin rod, because slender rods also we treat them as a wire, so we find the center of line for them. If it's a straight line or it's a straight slender bar, the center ends up being on the bar or on the wire. But if it's curved or twisted, the center can be anywhere. For that, x bar, it becomes integral x dl over integral dl, and y bar becomes integral y dl over integral dl. Right? What is dl? dl is a small element of this. So this element here, we had in three-dimensional space, we had t, dv, dm. Here we have dl as an element. Following the same logic, you can find this. If I'm gonna get this straight line right first time. This is coordinates of the centroid of a line, or of center of a line. And as I said, you could be trying to find the center of a wire. You could be trying to find the center of a very, very slim rod. Right? Same story. Now, it all depends on how can we calculate these integrals.